Namaste everyone. So let us continue the chapter surface areas and volumes, exercise 13.2 with question number 5. So there are 4 remaining questions in this exercise, that is 13.2. It is totally based on concept of volume. So this is very important question number 5. So see the textbook. Given a vessel is in the form of an inverted cone. You can see the vessel which is of inverted cone. Its height is 8 centimeter. Means what? Height of the cone is 8 centimeter. You can see I have written here height of the cone is 8 centimeter. And which is open in 5 centimeter. Means its height is 8 centimeter and the radius of its top which is open is 5 centimeter. So what is the radius of the cone given? 5 centimeter. Next, it is filled with water up to the brim. Means up to the opening of the cone, the water is filled inside the cone. Next is given, when lead shots, it is filled with water up to the brim. When lead shots, each of which is a sphere of radius. So, you can see these are the lead shots. We don't know how many lead shots you are putting in the cone, but is giving the radius of the lead shot is 0.5 centimeter and the lead shots are in the shape of what? In the shape of sphere. And the radius of the sphere is given 0.5 centimeter. Now, I should find when you put certain lead shots in the conical vessel which is filled with water, what happens? He is telling that 1/4 of the volume of water flows out of the cone. So, nothing but what you understood from this, n number of lead shots. Suppose think that these lead shots are n. We don't know how many lead shots. When you put n number of lead shots in the conical vessel, the 1/4 volume of the cone water falls out of the cone. Means what? That is the weight of n, that is volume of n lead shots is equal to 1/4 the volume of the cone. Because when you put n lead shots in the cone, 1/4 of the volume of water flowing out. So it is nothing but volume of n lead shots equals to 1/4 the volume of cone. So now for that we have here 2 3D figures. One is cone and one is sphere. So what we want for cone, height is given, radius is given, and for sphere radius is given. Note it, radius of cone and radius of sphere are different. So I have taken small r and capital R. Now what I have to find, actually we have to find how many lead shots you are putting in the cone such that 1/4 of the water will fall out of the cone. So I should find the number of lead shots. So let the number of lead shots be n. So according to question, n into n lead shots into volume of 1 lead shots means n times the volume of lead shots is nothing but 1/4 the volume of cone. Because when you put so many lead shots, 1/4 the water is coming out. So it is nothing but the volume of whatever lead shots you are putting inside is equal to 1/4 the volume of cone. Suppose instead of cone if you had given cylinder, so you have to write 1/4 the volume of cylinder. So n into, what is volume of lead shot? Lead shot is in the shape of sphere. So 4/3 pi r cube. Little calculation is heavy here, but simplify that and do it properly. So 1/4 into volume of cone is what? 1/3 pi r square h. Now substitute n into 4/3, capital R is 0.5 cube equals to 1/4 into 1/3 into r. What is r here? Radius is radius of the cone is 5. So r is 5 and one more r is 5 and h is 8. And you can cancel here itself. 4 ones are 4 twos are. So other numbers you can't cancel, keep as it is. And just keep in mind that 0.5 are writing how many times? 3 times. So this part I am writing as it is. 4 is cancelled. So 1/3 is remaining. Write as it is. In numerator what are remaining? 5 into 5 into 2. 5 into 5 into 2. So this part here whatever I have written same. And 3 also have to write same. 1/3 into 5 into 5 into 2. And this left hand side I am taking to right hand side. What happens? 4/3 becomes 3/4. It becomes reciprocated. Next, 0.5 whole cube comes in the denominator. How many times? 3 times. 0.5 into 0.5 into 0.5. So what I did, I sent the left hand side terms to right hand side. Now anything can be cancelled. Once you check, 3 ones are 3 ones are cancel, 2 ones are 2 twos. Now remaining whatever you have, take it again. What is numerator left here? 5 into 5. Right, 5 into 5 as it is. And denominator you have 0.5 into 0.5 into 0.5. When you remove the decimal point, it becomes 5 by 10, 5 by 10, 5 by 10. After reciprocates, the 10 will come in the numerator. So, how many times you remove the decimal? 3 times. So, that is 10 into 10 into 10. Divided by 5 into 5 into 5, right, as it is. And what is remaining here? 2. Now, try to cancel. Here 1 5 gets cancelled. Another 5 gets cancelled. 5 ones are 5 twos are 2 ones are 2 ones. Everything is cancelled, leaving 10 into 10. So what is 10 into 10? 10 tens are 100. So what is the conclusion? 100 lead shots. When you put 100 lead shots in the conical vessel which is filled with water, 1/4 the water volume of cone will fall out. That is, when you put 100 lead shots inside the cone, 1/4 the volume of the cone, that much of water will fall out of the cone. So that is the concept. So very important question. So work hard among it. And they may change the number. So be careful. They may change the number or they may change the shape of the vessel also. Concept will be same. Now the next question is question number 6. Given a solid iron pole consists of a cylinder of height 220 centimeter and base diameter is 24 centimeter. So here you have an iron pole which is cylindrical in shape, whose height is 220 centimeter and diameter is 24 centimeter. So what will be the radius? 12 centimeter. And next what is given, which is surmounted by another cylinder. So upon this there is one more cylinder whose dimensions are, height is given 60 centimeter and radius of this cylinder is given 8 centimeter. Concentrate, both 3D figures are cylinders only here, but the diameter and height of this cylinder and this cylinder both are different. And he is asking, find the mass of the pole. Means what? I should find the weight of the pole, given that 1 centimeter cube, means 1 centimeter cube volume of this pole has 8 grams mass. So I should find this total. This pole is in shape of this, that is, this pole, overall pole consists of 2 cylinders. One cylinder with height 220 and radius 12 and another cylinder with height 60 and radius 8. Now I should find the overall weight of this pole. Means it has 2 cylinders. So now for that, so little confusion. Every time we have 2 different 3D figures, but here you have same 3D figure, that is cylinder itself. But when you, so be careful when you are writing, because here also you have H, here also you have H and R. But try to write different alphabet. Here I have taken small h and small r, and here I have taken capital H and capital R. If you won't take this, again you take all common, so it goes wrong. So be careful. When the dimensions are different, change the alphabet. So now we have the dimensions of upper cylinder and also the bottom cylinder. Now what is volume of poles? You have 2 poles. So volume of poles equal to, it is cylinder shape. So here we are adding. I said already in the last video, when you are going to add or when you are going to subtract in case of volume, you are adding when it is one upon the other. When the 2 solids are one upon the other, then you are adding. When there is a cavity from the given solid, then we subtract. So whichever shape you have done the cavity, that particular volume is subtracted from the given block. But here there is no cavity, so one cylinder is upon another cylinder, so we have to add the volume of this cylinder plus volume of the first cylinder. Now the volume of one cylinder is, this cylinder is pi small r square small h plus pi capital R square capital H. So take pi common in both and write as it is in the bracket remaining. So write pi is given in the bracket, use 3.14. If we mention use 3.14, you have to use what he has mentioned, 3.14, and small r is 12 into 12, small h is 220 plus capital R is 8 into 8 and capital H is 60. Now multiply all this 12 into 12 into 220 you get 31680 plus 8 into 8 into 60 is 3840. Add these two we get 35520 and multiply with 3.14 we get 111532.80 centimeter cube. So this is the volume of the full pole. But he is asking the mass of the pole. But given 1 centimeter cube has how many grams of that metal? Because it is made up of metal. 8 grams of metal is used to make 1 centimeter cube of that pole. So now I want total weight of that pole. So mass of the pole is nothing but volume into 8. So volume is 111532.80 into 8 multiply. We get 892262.4 and I am converting into, till here it is grams but I am converting into kg. So to convert gram to kg I have to divide by 1000. So when you divide you have 3 zeros here. This points comes to before 3 decimals. So it becomes 892.2624. But after 0.2 many decimals no need to write. You can write up to 2 decimals. And you can see the third decimal is 2. So no need to add anything. So it becomes 892.26 kg. So what is the meaning of that? 892.26. After nothing is there, it is understood 260 grams. 892.26 kg is the mass of this given pole. The next question is question number 7. Given a solid consists of a right circular cone of height 120 cm and radius 60 cm standing on a hemisphere of radius 60 cm is placed upright in a right circular cylinder full of water such that it touches the bottom. So little confusion question. Here you have three 3D figures. One is cone, hemisphere and cylinder. So what they have done? A cone of height. What is the height of the cone given? 120 centimeter and the radius of the cone is 60 centimeter, which is mounted on a hemisphere and radius is also 60. Means the radius of hemisphere and the cone is same. Height of the cone is 120 centimeter, which is immersed. Means they kept both the hemisphere and the cone upright in a cylindrical vessel filled with water. Means the cylinder is filled with water. Okay. So now the cone and the hemisphere arranged like this in the form of this shape and they kept inside the cylinder upright such that this touches the bottom of the cylinder and the cylinder is filled with water. Now what I should find? He is asking find the volume of water left in the cylinder if its radius of the cylinder is 60 and its height is 180 centimeter. Here already has given 180, but even if you won't give height of the full cylinder also you can find. How you can find? The height of the cone, that is 120 plus the radius of the hemisphere 60. 120 plus 60, 180. But in the given, he has given in the question height of the cylinder also 180 centimeter. Now, if you observe the diagram, the radius of cone, hemisphere and cylinder all are same. So what is the radius? 60, 60, 60. And height of the cone is 120 centimeter and height of the cylinder is 180 centimeter. So I have used here small h and there capital H. So what I should find? The volume of water left in the cylinder. Nothing but I said already, in case of volume, we subtract when there is a cavity. So when you remove something from the wood. So if you compare this, it is also almost like same. But here when you keep this, that is hemisphere with cone inside the cylinder, some water will fall out. So only some water is remaining, some amount of water is remaining in the cylinder. He is asking how much water of volume water is left in the cylinder. So how to find the volume of water left in the cylinder? When you keep cone and hemisphere, then only the water comes out. So what I have to do? I have to minus the volume of hemisphere and volume of cone from the volume of cylinder. Nothing but cylinder is filled with water. So in that part of the water fall out because you kept these two, that is cone and hemisphere. So volume of water left in the cylinder equals to volume of cylinder, because cylinder is big vessel which is filled with water. So from this cylinder only water comes out. Because of what? Because of cone and hemisphere. So volume of cylinder minus volume of cone minus volume of hemisphere. So you have to subtract volume of cone and the volume of hemisphere from the cylinder. So even when there is a cavity also we are doing subtraction. In this case also we are doing subtraction. So what is volume of cylinder? Pi r square h minus 1 by 3 pi r square h is the volume of cone. 2 by 3 pi r cube is the volume of hemisphere. Now take pi r square common in all the three. Remaining h minus h by 3 minus 2r by 3. So pi is 22 by 7, r is 60 into 60, bracket h is 180 minus 120 by 3 minus 2 into 60 by 3. So simplify 3 into 20, 20 side will go, 3 40s are, and this all remains as it is. So when you multiply 22 into 60 into 60, we get 79200 into, just you can look it here, 180 here minus 40, 22s are 40, 40, 40, 80. So 180 minus 80 is 100 and down you have 7. So keep as it is. This is the volume of water left in the vessel in centimeter cube. So if you want to convert in meter cube, so what I have to divide or multiply? Yes, I have to divide, because centimeter is smaller unit, meter is a bigger unit. So always remember, to convert meter to centimeter you have to multiply by 100. To convert centimeter to meter you have to divide by 100. But here how many centimeters you have? 3. So you have to divide 3 times. 100 into 100 into 100 and 7 as it is. So this 100 gets cancelled. 2 zeros gets cancelled. What is remaining? 792 divided by 100 into 7 is remaining. First cancel this with 7 table and 100 you keep point from right side after 2 decimals. We get 1.13 meter cube of water is left in the cylindrical vessel after you put a cone and hemisphere in the vessel, and that vessel which is filled with water. So volume of water left in the cylinder is nothing but whatever you keep the solid inside the given vessel, you have to subtract from the given vessel. So this is little different question. Try to concentrate. The last question of this exercise is question number 8. Given a spherical glass. So you can see this is a spherical glass. That is, if I put a dotted line, it will look like a sphere. As a spherical glass vessel has a cylindrical neck. So what is the neck? Shape of the neck here? It is a cylindrical neck it has, whose diameter is 2 cm and 8 cm long. So what is the diameter of this? Given 2 cm. What is the diameter of cylinder? The diameter of cylinder is 2 cm and the height of the cylinder is 8 cm. So this is the neck of the cylindrical neck of the spherical flask. So for a spherical flask you have a cylindrical neck like this. The diameter is 2 and the height is 8. And what about sphere? Given the radius of the sphere is given, that is diameter is given 8.5. So from here to here the diameter is 8.5 centimeter. Then what will be the radius? 8.5 by 2 centimeter. So now what is asking? By measuring the amount of water it holds, a child finds, means already answer is given, a child finds its volume to be 345 centimeter cube. That means a child measures the water in this flask. That is what I should do. If according to that I should add the volume of sphere plus volume of cylinder. If I ask, I will get the volume of water inside the vessel. And already answer is given. What is the answer? 345 centimeter cube. Check whether she is correct or not, taking the above as inside measurements and pi as 3.14. So now we know the diameter of the sphere is 8.5, radius is 8.5 by 2. Don't cancel this because in formula we can cancel 2 easily. So cylinder is H, that is 8 cm, diameter is 2, radius is 1. Now volume of water in the vessel equals to, here I am not doing any subtraction because nothing, means no 3D figure is inside any vessel. So it is one upon the other. So what you have to do here, volume of sphere plus volume of cylinder. What is volume of sphere? 4 by 3 pi capital R cube plus volume of cylinder is pi small r square h. So in this only you can take pi common. Remaining 4 by 3 r cube plus r square h. Pi he asked to use 3.14. 4 by 3 into r cube is 8.5 by 2, 8.5 by 2, 8.5 by 2. So I said already don't cancel 2 here because you can cancel here. 2 2s are 4, 2 1s are 2. So in denominator what is remaining? 3 2s are 6 and in the numerator you have to multiply 8.5 into 8.5 into 8.5. How much? 614.125 plus 1 1s are 1 into 8 is 8. And if you take LCM of here 6 and here 1, you have to multiply this by 6 because LCM is 6 and 1 LCM is 6. Here you have to multiply by 6 and here you have to multiply by 1. So what we get? 614.125 plus 48 divided by 6. Add this, divide by 6 and multiply by 3.14. We get 346.29 centimeter cube. But we got the volume of water as 346.29. But in the question he has given 345 centimeter cube. So it is incorrect. So what the child done, the volume of the water inside that particular vessel, what he has given in the question is wrong because the answer is this. So it is incorrect. So with this I completed the concept of volume, that is exercise 13.2. I hope everyone are following, and after completing exercise 13.1 and 13.2, many of you have little confusion when we have to add, when we have to subtract in case of area, and when we have to add and subtract in case of volume. So for that, a quick little with one or two examples, let me explain the difference of subtraction and addition in both the cases, that is area and volume. So as I said, I am going to explain at the end of the exercise 13.2 what is the difference between addition concept and subtraction concept in case of area and in case of volume. So here I am not teaching in depth with, no, I am not finding the solution, but only with the diagram I want to explain you where in which cases we do addition and in which cases we do subtraction. So you can see this part I have taken area and I have drawn some diagrams here. You can just observe. In these cases, here I have given two diagrams here. In these two cases, we are adding in case of area. And in these two cases, we are subtracting in case of area. Why? So listen carefully. Here, when you observe this block, you have two 3D figures. One is cone and one is cylinder. The diameter of the cone and the diameter of the cylinder both are same. That's why you are adding here. Understood? The diameter of the cylinder and the diameter of the cone is same. Nothing is left out. If you observe here, it is left, this portion is left out. You can see from your eyes. But here, this part, nothing is left out. Exactly, it is coincided. So, if I ask you, suppose think that this is closed. It is a wooden block. This is also wooden and this is also wooden. If I ask you, think before I tell. So, what is the area of this solid? Yes, CSA of cylinder, because I can see only CSA of cylinder plus I can see the CSA of cone. This middle circle I cannot see because it is coincided. So don't add this. But you can see the base of the cylinder. Understood? The top of the cylinder and the base of the cone is coincided. So this part we cannot see. I said already in area, whatever you can see from your eyes, that should be taken as a area. So here I can see the curved part of the cylinder, curved part of the cone and the base of the cylinder. So that is CSA of cylinder is what? 2 pi RH. CSA of cone is pi RL and plus area of this base is pi R square. Suppose if it is a conical tent, it is not a solid tent. Tent is on the ground. So this part also you cannot see. So that time this also you should not include. Now coming to this, you can see here also the diameter of the, what is that, hemispherical bowl is exactly equal to the diameter of the cone. So when I asked to find the area of this 3D block, I can find what part of the cone you can see. you can see the curved part of the cone. This part you cannot see because it is coincided with the hemisphere. So curved part of the cone can be seen and the curved part of the hemisphere can be seen. So what will be the formula? CSA is pi RL and plus this CSA is, what is CSA of hemisphere? 2 pi r square. So this will be the formula to find these two. I hope everyone are following. So when you have these type of, I cannot explain all, but you should have an idea when the diameter of the 2 or 3 figures is same, then you are going to add in case of area. It's very simple. Now, when you are going to subtract, so I have given example 2 diagrams here. You can just observe the diameter of the cylinder is bigger and the diameter of the cone is smaller. So when you just look at the front view of that here, this is the circular part of the cylinder and this is the circular part of the cone. So where this part you cannot see. This part you cannot see because it is coincided. And this part you can see from your eyes. So that's why here you have to subtract. What you have to subtract? Remember always when the diagram is like this. So down the base which is bigger here, the cylinder is bigger. Volume of cylinder is bigger or area is bigger than the cone. So take the full block TSA. And I am telling again it is made up of wood. If it is made up of wood, I am telling take the full TSA of the bottom 3D figure, whatever you have. What you have here down, you have cylinder. So take total surface area of cylinder minus, if you subtract this cone. Why? Because this part cannot be seen. So if you minus, then this part you will get. So don't take CSA, you have to take TSA, means the curved part of the cylinder plus because this base of the circle is completely seen and this is not seen completely. So from the TSA, if you remove the area of circle of that cone, then you will get this part also. Understood? So, and plus what part of the cone can be seen? Curved surface. So CSA of cone is pi r. So overall, when they give like these blocks, whichever is big, so which is the full block here big and which is mounted, the cone is mounted on a cylinder. So this is big, therefore TSA of this cylinder minus area of this circle plus CSA of the cone. Very simple. Now here, just to recall, down what you have? Hemisphere. So TSA of hemisphere minus the area of this cone, area of this circle. If you do, you will get this part, empty part. So TSA of hemisphere minus area of this circle plus CSA of cone. I hope everyone understood. In case of area, when you have to do subtraction, first thing is when the radius is not same. When the radius of 2D figures, 3D figures are not same, then you go for subtraction. That is one point to remember. And the second point, what I have to take for subtraction? That is total surface area of the base 3D figure minus area of the base of the top second 3D figure plus the curved surface area. You can see this also. So like this, any n number of diagrams you can draw on your own and try to analyze the difference between addition and subtraction in case of area. Next, coming to volume. Volume also we have done addition and also subtraction. So when we do addition. Now listen very carefully. When the diameter of, I said in case of area, diameter of the cone and cylinder should be same, then only you can add. But in case of volume, even though the diameter is different, yes, you can say diameter of the cylinder and the diameter of the cone is different, but still we add volume of cylinder plus volume of cone. Very simple. Here you are not subtracting anything, addition, because it is one upon the other, even though the diameter is different. Here you can see the diameter is same. Here also you are adding the volume of cylinder plus volume of cone. So in both the cases, when diameter is same or different, you are going to add the volume of these 3D figures. Next, coming to subtraction concept. So, in case of volume, you do subtraction only when you do a cavity in the block. So, you can see this is a cavity. Which cavity you have removed? Conical cavity. So, what you subtract? The solid is cylinder and the cavity is made up of cone. So, volume of cylinder minus volume of cone. Very simple. Whichever cavity you have, that you have to remove. Suppose you have 2, 3, more than one cavity. Suppose 2 cavities are there. Remove minus 2 times of that volume. Like you have pen stand, 4 cavities. We removed 4 cones. So, similarly here, 1 is there, you remove 1. So, one more. Here is the cavity. But in this question, this is not a cavity. But you kept one vessel which is in the shape of hemisphere along with a cone and kept inside the cylinder which is filled with water concept. If it is water concept, if this vessel is filled, keep in a cylindrical vessel, then automatically some water of the water inside the cylinder will come out. So in this case also we are doing subtraction. Suppose if they ask what is the volume of air also, you can take volume of air. Volume of air inside the cylinder or volume of water inside the cylinder is nothing but volume of cylinder minus volume of hemisphere minus volume of cone. So I hope everyone understood the first 2 exercises. 13.1 is totally based on area. So maximum people confuse with the area concept. So volume is little easy compared to area. So concentrate these type of questions in case of area. So I hope like this you can draw a few more diagrams on your own and try to analyze where you can do addition and where you can do subtraction. Why I am stressing again and again, because surface area and volumes, this year you may get for 5 marks or 3 marks. So instead of not analyzing the question properly, instead of losing the marks, so better understand properly. Now this is the end of area and volume concept. In the next video we are going to learn the next exercise, that is 13.3, which is totally based on somewhat that is melting concept. Means you are melting of one 3D figure and you are reshaping the another 3D figures. So that concept you are going to learn in 13.3. Thank you.